This lesson is on rational equations, solving rational equations. Okay, so that's when I'm going to have multiple fractions and solving an equation with them. So let's start off pretty basic. 5 over 12 minus 1 over 2x equals 1 over 3x. Okay? The first thing that I'm going to do, because I still have a subtraction thing going on here, is I want to find my LCD, my least common denominator. Okay, I've got a 12. That's my largest number. I can make a 2 into a 12 and a 3 into a 12. And I also have x's here, so I'm going to also have to have an x. So my LCD is 12x. Okay. Once you have your LCD, you're going to multiply both sides. It says both sides of the equation by the LCD. Okay, so this whole side is going to be multiplied by 12x, and this is going to be multiplied by 12x. Easy enough. But when I rewrite it, what I'm going to do is write it individually. So I essentially have a distributive thing going on here. So I have 12x times 5 over 12 minus 12x times 1 over 2x, and it's also going to be equal to 12x times 1 over 3x. Okay, the third thing that we're going to do is cancel out what we can. Instead of having to do all this multiplying and then dividing, I can cancel out here this 12. So I'm left with x times 5 over 1, which is just 5x. A negative 12. Oh, I can cancel out this 12 and this 2. I can divide it out by 2. So I'm left with 6. I can also cancel out a 6 and that x and the x. So I'm left with 6 times 1, which is just 6. Remember, guys, this is all over 1. I didn't think we needed to really say that, but it is. It's like multiplying across the top. All right, and here I can cross out the x's and divide out a 3. I'm left with equals 4 times 1, which is just 4. Okay. Now, just solve your equation. Add 6 both sides. 5x equals 10. X equals 2. Okay, so solve is the last step. Okay, pretty basic there. Now what we're going to do is we're going to solve with factoring. Okay, so this little portion is going to be on factoring, or with factoring, I should say. All right, let's say I have 1 minus 1 over x equals 12 over x squared. Okay. Now, the first thing I still have to do is find my least common denominator. Okay. I have no denominator here. I have an x, so it's going to have to at least be an x, and this is an x squared. So actually it's going to be x squared. So I'm going to multiply, just like we did here, both sides of the equation by the LCD. Okay? And then write it out separately. That'll help you. Okay, so I have x squared times 1 minus x squared times 1 over x. And that's going to equal x squared times 12 over x squared. Okay, good. Cancel out what you can. Nothing here. I can divide out one of those x's. I'm left with x and I can divide out both of those. All right, so x squared times x is still x squared minus x times 1 over 1, which is just minus x, equals just 12 over 1, which is just 12. Well, remember, whenever you see that exponent of 2, it's a quadratic. So that means I'm going to have to set it equal to 0 and factor, hence the with factoring part. So I can't move this x squared to the right. It'll make it a negative, and I can't have that. So I'm going to move this 12 over, okay? So I'm going to have x squared minus x minus 12 equals 0. And then I can factor what multiplies to negative 12 but adds to negative 1. Well, that's going to be x plus 3 and x minus 4. Set each of those equal to 0, just like we've done in the past. X equals negative 3, x equals positive 4. All right, and then you need to go. Then you can go back in and check. Does it work? For the sake of time, we don't have to check it here. You can, if you've got time, go ahead and do some, check that right here, plug it back into this original equation, okay? You're gonna have to check each of them, see if they work. All right, good, so that's with factoring. The next way we're gonna look at solving proportions. Okay, so let's say we have number 3, 4 over x plus 2 equals 3 over x plus 1. We are going to be using the cross product property. Which is fancy for telling us to cross multiply and then solve. So 4 times x plus 1 is going to equal 3 times x plus 2. 4x plus 4. We have to multiply it to distribute there. Equals 3x plus 6. And then VC. 4 minus 3 is x. 6 minus 4 is 2. X is 2. You could also plug that back in to check. Okay. All right, and then let's do one where we need to check the extraneous solution. Okay. So if we had 6 over x plus 5, x plus 3 over x plus 5, and it's asking us to check that extraneous solution. Okay, I've got to first solve for x and then see what we've got. Okay, so again, I'm going to use that cross product property. 6 times x plus 5 is 6x plus 30. Cross multiply. Okay, now I'm going to have to FOIL this x plus 3 times x plus 5. Once you get that, you have x squared plus 8x plus 15. And I see that's squared, so I know I'm going to have to factor here somewhere. I can't move this all to the left. That'd make my x squared a negative, and I can't have that. So I'm going to have to move the 6x minus 30 and move it to the right by subtracting and subtracting. Okay, 0 equals x squared. I have 8x, bring this over by subtracting, so I'm plus 2x. 15, bring it over by subtracting 30, I'm left with negative 15. What multiplies to negative 15, but adds to 2, x plus 5 and x minus 3, which set those equal to 0, x equals -5, x equals 3. And we're going to plug it in to see if it works. That's the part where we're checking. We're checking that extraneous solution. All right, so plug in the 5 first. If x equals -5, 6 over -5 plus 5 equals -5 plus 3 over -5 plus 5, which is just 6 over 0 equals -2 over 0, which is undefined, as we know. We knew that extraneous solution could not have been that -5, okay? But now we also were able to solve for the correct solution. Let's double check, because sometimes it doesn't work both ways. Maybe we made a mistake, I don't know. But you need to make sure that you're checking both of those. So if x equals 3, we should have 6, 3 plus 5 equals 3 plus 3 over 3 plus 5. 6 over 8 equals 6 over 8. Look at that, and it works. So x equals 3 is our solution. The code word for this lesson is Ed Westwick. You're welcome, Alyssa.